All right, let's talk about the invisible power grid that runs our entire planet. We're talking about the flow of energy through an ecosystem. And, we're going to break this whole thing down using an analogy that you've probably got in your pocket or on your desk right now.
So I know this sounds like the start of a weird joke, right? An eagle, a phone battery, what could they possibly have in common? But seriously, stick with me here, because the answer to this question gets at one of the most fundamental rules of all life on Earth.
And here it is. The connection is actually pretty simple. They're both constantly dealing with the exact same problem. They need energy and they can't just hold onto it forever. Your phone's battery drains, and every single living thing, from a tiny blade of grass to a huge blue whale, needs a constant recharge just to keep going.
Okay, so if the whole planet is just a massive collection of devices that are always running low on power, where does all the juice come from? Well, let's meet the key players in this biological power grid. First up, we've got the producers. Think about plants, algae, some types of bacteria. These guys are basically the wall outlets of the natural world. They plug directly into the ultimate power source, the sun, and through photosynthesis, they create a 100% fully charged batch of chemical energy.
And then you have, well, pretty much everyone else. These are the consumers. These are all the devices that can't just plug into the sun. So, from tiny little insects to massive grizzly bears, they have to get their energy by plugging into, or, eating, other organisms.
So how exactly does that charge get from the wall outlet all the way to that final device? The easiest way to picture this is with something we all learned about in school, a food chain.
Think of it like a simple charging cable. You start with the producer, the grass. That's our wall outlet. Then, a grasshopper, our first device, comes along and plugs in by eating it. Then, a frog plugs into the grasshopper. And finally, an eagle plugs into the frog. See? It's just a direct line of energy transfer, one step to the next.
But, of course, nature's never that neat and tidy. An eagle doesn't only eat frogs, and frogs eat a lot more than just grasshoppers. The reality is, it's way, way more complex than a single cable.
And this is where we get the idea of a food web. It's not one charging cable. It's more like a massive, tangled power grid where energy can flow in all sorts of different directions. A single producer, like grass, might be the power source for dozens of different consumer devices.
Now, we've got all this energy flowing from one organism to another. But there's a catch, a really big one. Every single time that energy gets transferred, a huge chunk of it just disappears. You can think of it like a hidden tax on every single meal.
And that's the million-dollar question, isn't it? If that eagle eats the frog, does it get 100% of the energy that was in the frog? No way, not even close. So where does all the rest of that power actually go?
To wrap our heads around this, scientists use a really great model called the energy pyramid. And honestly, the shape itself tells you the whole story. As you go up the pyramid, up the food chain, the total amount of energy that's available gets smaller and smaller and smaller.
And here is the absolutely mind-blowing number. Get this. At each step up that pyramid, roughly 90% of the energy is lost. It's just burned off as heat while that creature is, living its life, moving around, breathing, just staying warm. That means only about 10% actually gets stored and passed on.
So here's the real takeaway. That charging cable we talked about, it's incredibly leaky. And this massive energy drain is the fundamental reason why our planet can support billions of tons of plants, but way, way fewer top predators. It's also why something like overfishing can be so devastating. When you remove those top predators, there just isn't enough energy at the top of the pyramid for them to easily bounce back.
So if energy just flows in one direction and mostly leaks away, what about the actual physical stuff? The atoms and molecules, the hardware that make up all these organisms. Does that just disappear too?
Thankfully, no. This is a crucial difference. While energy flows, matter cycles. This incredible process of recycling the planet's building blocks is called bio-geo-chemical cycles. To go back to our analogy, energy is like the electricity, which gets used up. But the atoms, the carbon, the nitrogen, the oxygen, that's the phone's hardware. It can be broken down and reused to build new batteries over and over again.
And these cycles are happening literally everywhere all the time. The carbon in the breath you just let out was probably part of a plant not too long ago. The oxygen you're breathing in right now is part of this constant global exchange. It's amazing.
Let's just take the nitrogen cycle, for instance. The air we breathe is mostly nitrogen, right?
over 70%. But here's the wild part. Most living things can't use it in that form. It has to be fixed by special bacteria in the soil, which turn it into something plants can actually absorb. That nitrogen then travels up the food web, building our proteins and DNA, and eventually other microbes send it right back into the air. It's a perfect, sustainable recycling system.
So to bring this all back together, one source I read put it in a way that just clicks perfectly. The energy starts at 100% with the producers, but with each transfer, the battery life just gets lower and lower, until the apex consumer is running on just a tiny fraction of that original charge.
And that leaves us with one last really cool thought. If this entire system is so ridiculously inefficient, losing 90% of its energy at every single step, how on earth has life's global battery not just died out completely over billions of years? The answer, of course, is that it's constantly plugged into a power source of almost unimaginable scale: our sun. Thanks for tuning in.